All right, my friends. So our Quizizz activity for 7.2 is on the board now, screen in the video. I'm going to put our templates that we're using. So here's the difference of perfect squares, which is a minus b times a plus b. And on the other side over here, a squared plus 2ab plus b squared simplifies to a plus b squared. And then if it is subtraction, we have a squared minus 2ab plus b squared, and that gets us that a minus b squared. So for this specific example, we have two terms and we're wanting to factor it. So this is the difference of perfect squares. The square root of x squared is x, and the square root of 25 is 5. We do have a subtraction sign in the middle, so we're going to do x plus 5 times x minus 5. So you're going to select that blue option. Beautiful. And then we'll go to the next question. So this is 3m plus 1 times 3m minus 1. So we have a plus and a minus, so we're talking about over here, the difference of perfect squares. So to put it into, when you multiply this out, you want to figure out what 3m squared is, which is 3m times 3m, which gets 9m squared. And you want to figure out what 1 squared is, which is just 1. So we're going to have 9m squared minus 1, using that difference of perfect squared form. Beautiful. Okay, this next one is, oops, let me clear my board. That was an A. Okay. This next one is u minus v times u plus b. So again, we have a minus and a plus, so we're looking over here on the left. So it's a squared minus b squared. So our a in this case is u. So u squared is u squared. And then our b is 5v. So 5v squared is 25v squared. So we have u squared minus 25v squared. Beautiful. Okay, this next one has 3 terms, so it's going to be one of the perfect square trinomials. We see addition, so we're going to use this one at the top. To factor it, we take our first term, which is a squared, take the square root to get x, or x squared, sorry. And then our last term, which is 144, and the square root of that is 12. Since it's addition, we're just going to have x plus 12 squared. Just like that. Perfect. Okay, this next one has 3 terms, but we see a subtraction sign. So now we're going to have something minus. So we know it can't be this one, and it can't be this one. So the square root of x squared is x, and the square root of 225 is 15. So we're going to do x minus 15 squared. Beautiful, y'all. Nice job. Okay, this next problem has a minus and a plus. So when we have 1 minus and 1 plus, we're looking over to the left at the difference of perfect squares. Our first value is 7r. So when we square that, 7 squared is 49, and then r squared. And then we have a 6, and when we square that, we get 36. So it's the difference of perfect squares, so it's 49r squared minus 36. Perfect. Which of the following is an example of difference of 2 squares? So we have to have difference is subtraction. They all have subtraction, so that's good. Then we're looking for perfect square numbers. So 49 is 7 times 7. M squared is m times m. So that one looks good. That one looks possible. Let's keep going. A is just A. That is not a perfect square, so that's not going to work. 100 is a perfect square, 10 times 10. But 2 is not a perfect square. There's no number that you can multiply by itself to get 2. And our last option, 25 is a perfect square because it's 5 times 5. 10 is not a perfect square. There's, again, no number you can multiply by itself to get 10. Multiply. So that won't work. So our first option was correct. Beautiful. Let me get rid of these X's real quick. Which of the following is not a perfect square trinomial? Okay, so first thing, they have to have 3 terms. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's all good. They all have 3 terms. They're all trinomials. Now the first term has to be a perfect square. This is x times x. This is x times x. This is x times x, and this is x times x. So they all start with a perfect square. The third term also has to be a perfect square. 64 is 8 times 8. 20, I don't know about that one. 196 is 14 times 14. And again, if you weren't sure, just go to your calculator and test them. Right? If we typed in the square root of 20, we get this messy decimal, which tells us it is not a perfect square. And of course, 144 is 12 times 12. So this one is not a perfect square because 20 is not a perfect square. Beautiful. Question 9, which of the following pairs is the correct factor of the trinomial x squared plus x minus 12? Now this is a throwback. This is not a perfect square trinomial. This is when our a value is 1. So we want to find 2 numbers that multiply to a negative 12 and add to that 1x. So 3 times 3 and negative 4. 3 times negative 4 is negative 12. 3 plus negative 4 is negative 1. So that's not going to work. Negative 3 times 4 is negative 12. And negative 3 plus 4 is 1. So that one will work. 6 and negative 2 or negative 6 and 2 would add to a 4 or negative 4, which is not what we want. So that's the only option where it will work. So that was just a little throwback from last week. Clear the board up. What is the special product? What special product is x plus y times x minus y, which is equal to x squared minus y squared? So this is the difference of perfect squares. So the special product in the front is the product of the sum and the difference of 2 squares. So we're going to choose that first option. Beautiful. If 2x plus 3y times 2x minus 3y is 4x squared minus 9y, what is 6? That should be a y squared. What is 6b plus 9c times 6b minus 9c? So we want to square the first term. So 6b times 6b, or 6b squared. 6 squared is 36, and then we have a b squared. Our second term is a 9c, and when we square that, 9 times 9 is 81, c squared. So we have 36b squared minus 81 c squared. So we want to make sure there's a subtraction sign there and that we've squared those terms appropriately. Beautiful. Why are special products important in algebra? Because they are unusual products that have mysteries, because they are techniques that make it easier to solve product of polynomial, because they make mathematics more complex, or because they're methods to apply the law of exponents, making it easier to solve. So we want to choose this one. These are techniques, these are special tricks that make it easier to solve products of polynomials. They're patterns that we've noticed. Beautiful. What is the product of x minus 5 times x minus 9? This is not a pattern that we're looking at. I just threw some in to practice what we learned last week too. So x minus 5 times x minus 9. When we're multiplying binomials, we can always make a box if we want. We have an x and a negative 5, and we have an x and a negative 9. X times x is x squared. X times negative 9 is a negative 9x. Negative 5 times x is negative 5x. And then negative 9 times negative 5 is a positive 45. We can combine these two terms. So we get x squared, negative 9x minus 5x. So we would just do negative 9 minus 5 is a negative 14x, and then plus 45 right there. Beautiful. Clear this up. In the product of the sum and difference of two terms, what are the factors? 25e to the fourth minus 81f squared. So the square root of 25e to the fourth. Well, the square root of 25 is 5, and the square root of e to the fourth is e squared. Remember, this is power over root. 4 divided by 2 is just 2. And for the next one, the square root of 81f squared, the square root of 81 is 9, and 2 over 2, the square root of f squared is just f. So we have 5e squared plus 9f and 5e squared minus 9f. We see that here, right? Yeah, perfect. Nice job, y'all. Select all polynomials that can be factored. Okay. X plus 1, there's not much we can do with that. There's no greatest common factor. There's no special pattern. That's not going to work. X squared minus 49. I see a difference. I see that subtraction. X squared is x times x. 49 is 7 times 7. So this is x minus 7 times x plus 7. So that one can definitely be factored. 2x cubed minus 6x squared plus 8x. It's not one of our patterns, but they do all at least have 1x. And the number 2 goes into 2, 6, and 8. So we can pull out a greatest common factor of 2x, and we'd be left with x squared minus 3x plus 4. And then over on the right, x squared plus 3x plus 2, this has an a value of 1. So we would want two numbers that multiply to 2 and add to 3, which could just be positive 2 and positive 1. So these last three could all be factored. Okay. Now there's 5 more questions on this Quizizz. I want you to try and work through those last 5 questions on your own. They're going to be talking about the special products, so make sure you have those patterns written down to support you. If you have any questions or need help from me, Let me know, my friends. You got this.